just open a page of the Google Colab like this. I think if you've logged into Google Gmail, you can open Google Colab and you can just use this like this, because see, most of the other Python IDEs are there, where you have to install each and everything in Python. That is, if you want to use a particular API, you have to install it and then only you can use it. But here, just by importing, you can use the Python APIs. Okay. So how this is a general purpose language? That's what you have to get to know, why Python is a general purpose language, and how it is related to MATLAB. That is, if you are very good in MATLAB, most of the things you will be getting to know if you are very good in MATLAB. How many? Maybe you would have learned. You would have learned MATLAB, right? Most of you. I think you would have used that MATLAB in while you are doing your DSP lab or anything like that. DSP lab, have you? That is filters and all. I think you would have done using MATLAB, right? Okay. Okay then. Anyway, I'll just teach you um, basic stuffs in Python, and then we'll go for the interfacing stuff. See, here this Python has a strong thing called duck typing. That is, it is the it has a characteristics called duck typing. That means that if it is a duck, and if it walks like a duck and quacks like a duck, it is a duck. That's what Python tells. That means that, see, f is equal to 10. 10 is a integer, right? 10 is a integer, and if you are saving that 10 to f becomes a integer, right? So this on compiling, it automatically gets to know that whatever assigned value is there, it is integer. So we don't have to tell that it is a integer. Usually what happens in C programming is, what you will do is you will declare int f, like this. You will be declaring. That is not needed while you are doing it in Python. You just have to assign a value which is integer, and it automatically gets the gets the integer type. So let us see how it is taking that. Okay, type of f is to get to know what data type f has taken. Okay, so we'll get to know what f has taken. So you have to run this. You have to click on this to run in Google Colab. You have to click on this to run. Okay, it is running, and can you see this? Type of f is automatically, it is taking it as int. So this is called duck typing. That means that if I had told you that if it walks like a duck and if it quacks like a duck, then it is a duck. If this number multiplies like a integer, adds like a integer, automatically it is a integer. So by compiling this line itself, on compilation it automatically finds out that this particular variable is an integer variable, and whatever number is stored, that is of type integer. So let us try just making it a floating point and check it, what happens to this. Okay, so automatically f becomes floating point number. Just by assigning a floating point number to that f, it becomes a floating point number. So this is called duck typing. So whenever you are using a Python code, you don't need a declaration. So you don't have to tell that it is int f, int g, float f, like that. It is not needed. So this is the duck typing. It is one of the prime characteristics of Python. And then it is a general purpose language. How Python becomes a general purpose language? See, when you are talking about microcontroller, okay, when usually 8051 microcontroller, PIC microcontroller, many other microcontrollers are there. Each one has its own IDE, that is integrated development environment. Okay, so integrated development environment. Okay, so this I think you would have if you have worked on 8051 or ARM processor or any other processors, each one has its own integrated development environment. So one of them is Keel. I think if you would have worked on Keel, maybe you will be knowing what is the integrated development environment, where you can develop a C programming code for a particular microcontroller. See, but that is for only a microcontroller. It doesn't work on a OS. It is a application which you will be installing and then you will be making it to work. But when it comes to Raspberry Pi, that is Python, it is a general purpose language. General purpose language. Why? Because you can use that in microcontrollers like Raspberry Pi. Sorry. Pi and BeagleBone is there. BeagleBone, it was a previous one. BeagleBone was a previous previous microcontroller or the complete system on chip that was used before Raspberry Pi. Most of us, those who have worked on Raspberry Pi will be knowing that BeagleBone is a previous version, nearly previous version of Raspberry Pi itself, you can tell. And in Raspberry Pi, it started with 1, 2, 3 like that, and 3 is very famous. Raspberry Pi 3 is very famous, and then 4 now it has come. Just 1 year it has come. Raspberry Pi 4 we will be using it. 1 GB or 4 GB RAM. It is dependent on the RAM. And if you are talking about the memory, it will be like 16 GB or 32 GB memory will be there. That is ROM, read only memory. Okay, what is a RAM and what is a ROM? Any idea? In your CPU, what is a RAM and what is a ROM? Any one of you? RAM is random access memory, and ROM is read only memory. Can you tell me what is that? You can only type because I am having a mic connected, so you can only type in the chat box. Any idea? Okay, I'll go there. Okay. What is Swati? You are telling about bits. Yeah, it stores. See, read only memory is the hard disk. Okay, hard disk means where software and OS everything is installed, and where we actually store is ROM. RAM is where temporary calculations happens. Okay, temporarily if you want calculations happening, then you will be using RAM. When it comes to Raspberry Pi, what are the two types of RAMs we have got? That is 1 GB and 4 GB, right? For Raspberry Pi 4, it is 1 GB and 4 GB. We have got two types of RAM, that is according to the amount of memory it shares while running, while compiling. Yeah, ROM permanently stores data, right? And that is what is hard disk. Whatever hard disk that you are having in your CPU, that is permanently it stores the data. But when it comes to RAM, what happens? Whenever calculation, whenever compiling is happening or interpreting is happening, during that time you have to that RAM will be getting used. See, if you want to have many applications running at the same time, what is more important, ROM or RAM? If you want multiple applications to run at the same time, yes, RAM, because it will be using using RAM for calculations at the time of compiling and interpretation. Fine. Okay then. Fine. And then, so this as I told you, Python is a general purpose language because it has programming options for microcontrollers. Like it is a Raspberry Pi is a processor. You can tell it as a processor which has okay, let us go to what is microcontroller and what is a microprocessor. Shall we check that? What is a microprocessor and what is a microcontroller? Whether the CPU that you are having in your home or in your laptop, what is that? Is that a processor or a controller? CPU. Yeah. Why is that so? Why do you tell it is a CPU? Why do you tell that it is a CPU? That is, see, CPUs has extendable RAM, right? You can, if you don't want 8 GB, you can remove it and you can use a 16 GB. If you don't want hard disk of 500 GB, you can remove it and you can use it for 1 TB, right? But when it comes to microcontroller, what happens? It is all fixed. Now tell me whether Raspberry Pi is a fixed processor or it is a controller. Can you tell me whether Raspberry Pi is a controller or a processor? No, only RAM. It is RAM is 1 GB and 4 GB. Yes, right. It is a processor because ROM is extendable, right? ROM. No, that is choosing is different. Actually, choosing is in 8051 also, 8051 and 8052. If you choose, then the memory is it is 256 KB ROM, and for 8052 it is 512 KB ROM. That is fixed, right? RAM is fixed in Raspberry Pi also, but what about the ROM? I told you 16 GB also we can put, 32 GB also we can put, right? So that's why I'm telling that it has a processor. It is because of that we can extend. Yeah, it can be extended. Yes, exactly. It can be extended. That's why I'm telling that it is a processor. Fine. So, and then we got it. General purpose here. What all we can do? Image processing we can do using Raspberry Pi. That is, there is a option of connecting a camera to it, and then image processing we can do. Yes, and then the microcontrollers option of ADC interfacing, yes, we can do, and then cloud interfacing, yes, we can do on Raspberry Pi. That what all we are doing it on Raspberry Pi with the help of Python coding only. We are doing that. Raspbian, see, you have a OS called Raspbian OS, which will be helping you to run Python on it. Okay, Python. You have a Raspbian OS, which is similar to a Linux. It is a Linux variety. Raspbian is a variety of Linux, and you can have Python IDEs to run on it. Fine. Okay. Okay. Then, so this is the base about how Python. We can tell this is the base of Python, like how what you need to know about Python before you start to know about Raspberry Pi's pin diagram. Okay. So now, say for example, if you are planning to write a code here for checking whether there is a in order to check whether there is a high in the heart rate or not, what we have to do, we have to take a variable and check whether it has become high or low, right? So what we can do, we can use if loop, right? So if is possible, if that particular pin, I am taking p as a pin, p it if it has occurred as p is equal to 1, okay, if it has occurred as 1, then for every condition you have to give a colon here, and it is a indentation, automatically it will indent, it has to be here, right? Usually where is the cursor, it has automatically come after if. That means that you don't have to use a open bracket and close bracket like how you do it in C programming. Automatically this indentation tells that it is inside the if loop. Okay, if p is equal to 1, what should I do? Count is equal to count plus 1, because heart rate count you are doing, right? Here already we have thought that it is a GPIO we are connecting to. Fine. So if p is equal to 1, p is the pin where heart rate sensors pin is connected. Okay, I'm just telling you. Okay, so let us see what happens. Now first p is equal to 1, I am making it intentionally, and count I am making it as 1 intentionally. So I don't need I don't need p to be told it is an integer and count to be told it is an integer because of the duck typing concept in Python. And I am just taking if p is equal to 1, count is equal to count plus 1. Okay, let us see if it is 1, right? Let us see what happens. Okay, now we have to print count, right? Print count, then only we'll know whether it has counted or not. Can you see this? So p is 1 now and count was 1 previously, so p is 1 right now, so that's why I'm checking if p is equal to 1 or not. Yes, it is 1 only. If it is yes, then count is equal to count plus 1. Let us just check with 0 now. 0, whether count will be incremented or not, we'll see. It has not incremented, right? It has given the same value of count before p is equal to 0 is checked. Okay, so this is a small program to check the count of heart rate. It is not the same, but a lot of things will come. We have to actually include the header files of Raspberry Pi, and we have to include the GPIO pins of GPIO. What is GPIO? It is general purpose input output, and also we have to include the pin of SPI interfacing. Everything we have to include. Whenever we start the program for Raspberry Pi, we have to include many things, like I am going to use GPIO. Yes, that we have to tell here. Import GPIO as GPIO, like that. That will come later on. And if you want SPI to be interfaced, for that also we have to import. So we have to tell this program that I am going to use Raspberry Pi only, and the code will be run on Raspberry Pi only in order to get the output. Fine, that's fine. Okay, then we'll see. Let us see the Raspberry Pi's pin diagram. Okay, so are you able to see this? I hope you are able to see this. Yes, yeah. Okay, no, fine. See, GPIO, what I told, GPIO is general purpose input output. Fine. So almost there are 40 pin GPIO available for this particular Raspberry Pi. You have 40 pin GPIO. So you can see this. 1 till 40, you can see. So the count will be like this: 1 2 3 4 5 6, like this we have to count. And 1 till 40, there are 40 pins for Raspberry Pi. Okay, so previously it was only 26 pin, but after model B plus, actually it became 40 pin GPIO, right? Okay, what all is there here? You can see here, that is here there is a power supply, 3.3 power supply, 5 volt power supply, right? And then you have grounds, you have got GPIOs, that is directly you can connect. See, if you want to connect the heart rate sensor, where you will connect? Directly GPIO 17th pin you can connect it. And I told you, here we have to check, right? We have to check the 17th pin whether it has become 1 or not. I hope okay, I hope you are getting it, right? What I'm trying to tell directly, because heart rate sensor, it is only a pulse, right? We don't need a ADC here because it is 0 and 1 only, so it is digital in digital already. So we have to give just directly to the GPIO pin directly. So once it becomes high or low or high and low, that count has to be taken. So this is the one that will be using it for the for this purpose. Okay, GPIO for heart rate sensor. And then we are having another two sensors, right? That is the ADXL sensor, and then another one is the BP sensor, right? So those two sensors, how it will be connected? It will be connected through MCP, right? Okay, so MCP 3004 will be taken, the output will be taken, and that will be connected to this MOSI and MISO. Okay, these are the pins that will be used for SPI interfacing, right? That is serial peripheral interfacing. So each one of the pin will just get to know. Okay, so here GPIO pin designated as a output pin can be set as high or low. So what you have to do is you can, here I told you we are connecting the heart rate sensor in this particular GPIO pin. So if it has to get the input inside, then it is called input pin. We have to set that pin as a input pin. If you want to give a output, then you have to set that pin as a output pin. Okay, so here you have to inform the in the code only you will be informing whether it is out pin or in pin. So for that GPIO is equal to out, GPIO is equal to in, like that we have to mention those code and all. We will be telling you, I will be teaching you. So this here, in order to tell whether it is a input or the output pin, we have to mention that. Okay, so GPIO pin designated as an output pin can set to high or low. The same way here also, read as input, I told you, right? Input will be 3.3 volt or 0, any one it will be reading it. Okay, so the pull-up resistors is mainly to maintain the voltage to 3.3 volt. So that is there in 8051 also. The same thing will be there in Raspberry Pi, already inbuilt it will be. Okay, pull up means if you are using multiple GPIOs at a same time, voltage will be getting down. So if you have to pull up the voltage, pull up resistors will be used. That is already that is configured already. Okay, so that is one thing. And then, so if you want to use a PWM, pulse width modulation, that is if you want to trigger a MOSFET, or if you want to trigger a particular motor to be on or off, if you are using a pump for switching on and switching off, during that time this PWM pins, that is almost, it is GPIO pins only. So all these GPIO pins we can use it for hardware PWM. Okay, and then what is this? SPI. This is what we are going to use, right? So there are two SPIs here. SPI is 0 and SPI 1. So if you are if you want to make this happen, like two patients data if you want to take, so this is the these are the pins that we can use, that is GPIO 10, GPIO 9, GPIO 9, 11 and 8. Okay, this is chip enable. If you want to enable SPI 1, SPI 0, you have to use 7th pin to enable SPI 0. Same way, if you want to SPI 1 to be enabled, then 17 and 16 you have to use for enabling this particular pin, and then these are the pins for getting the data. Okay, so this is for getting the data and this is for giving the data out. If you want the data to be got from the SPI interface, then MOSI, and if you want to give it outside, then MISO. This is the pin data. Fine. And then I2C is nothing but it is similar to the serial interfacing, where the data will be having a start data point and end data point. All those things will be available, and for that I2C you will have GPIO2 and GPIO3. That I2C's data you have to store it in a EEPROM. So for that GPIO 0 you can use and GPIO 1 you can use, where usually I2C is similar to this TX-RX only, but here the data will be stored in a EEPROM. That is the main thing. And here in serial interfacing, what happens, the data we have to store it and we have to use it for further application. So these two things we are not going to use anyway. We are going to use these two only, that is GPIO and SPI only we are going to use. So regarding this we will have a detailed discussion. Okay, so here numbers and all will be given, actually what GPIO general purpose input output is there, and all those things will be available. These are the pins we will be mostly using for getting the input and output. Okay, fine. So this is the this is how in Raspberry Pi the program output and all will be displayed here only. So those things will have a discussion in the coming classes anyway. So here see, you can see in order to make the GPIO to be high, that is used, right, for that we will be adding some lines in the code in order to make the GPIO to be used as a input or output. This is not this is not for Raspberry Pi 4, it is for Raspberry Pi 0 actually. So this will not be using. In the programming only we will be adding whether that particular GPIO we will be using it as a input pin or a output pin, and then we will be continuing it. Okay, so this is a base about what all pins are available in Raspberry Pi, and then this is how the code instead of using declaration, directly using the variables. These are the things we will be usually doing it on this particular Python platform. Okay, so if you got any doubts, you can just ask me through through this. You can just ask me and we'll have a discussion on that. Yeah, have you got any doubts? Can you? Yeah, that is for the serial interfacing actually. So that is MOSI is for input from the serial interface. See, actually when you are getting the Raspberry Pi's output, right? Whenever you are getting the ADC's output, these pins get the data in a serial manner. So that's why it is called serial peripheral interface. So MOSI and MISO, both these pins, I is for input, O is for output. This particular pin gets the data in a serial manner. Bit by bit it will receive it, and we can use it for storing that in the cloud. So serial peripheral interface, 1 byte at a time it will take and it will save it, and that we can directly send to the cloud. So whatever ADC's output we are getting, that will be coming to serial peripheral interface only. Either of these pins we'll be usually using SPI 0 only, because the four data we can easily receive using SPI 0. If there are more data, then only we'll be going for two SPIs here. So it is just how we receive the data that we for that there are procedures, like we have to chip enable. First we have to enable the chip, and by enabling the chip and disabling the chip, the data transfer will happen. So when to that procedure will be there. First we have to enable the chip, and then send the data, and again disable the chip, again enable the chip, send the data and disable the chip. Like that it will be happening continuously. So that for that, this MOSI and MISO will be helpful. That is for if you are receiving it, MOSI, that is input, MISO is for sending it through SPI. It is a two-way communication. So in the ADC's output, you can receive it using MOSI. Okay, so anything else you are? So each one of what I'll do is I'll be teaching you the interfacing of each. That is, first we'll be going with GPIO, and then we'll be going with GPIO interfacing we'll do, and then the MCP 3004 interfacing, how it happens, what is the code for that, how the interfacing is happening, how the code is working, all those things we'll have a discussion. And one by one we'll I think we'll be starting with the GPIO thing in the coming class. When you whenever you want, you just book it in the same link so that we can start with the programming portion of GPIO interface. And also maybe we'll have a hands-on on the Raspberry Pi itself, how it works, how it is. I'll also connect a camera where you can see the Raspberry Pi directly, and you can also, if until there is a physical class, that is until there is an online class, maybe we'll be having through Google Meet, and I'll also interface a camera where you can see the board directly. So that way I'll try doing it. And regarding the report things, right? See, what you have to do is whatever we are discussing, right? If you are able to make it as a notes, whatever we are discussing, then it will be easy for you to complete a report without plagiarism. So whatever we are discussing in the class, right, that if we are able to clearly make in notes, or if whatever video I have whatever class we have done right now, that if you are able to convert that into text, right, then it will be very easy for you. Without plagiarism, you can submit a report. Yeah. Anything else is there? If you want any doubts to be cleared, I'll be able to update you. See, 3.3 volt power, actually there are two things. Actually, what happens is regarding the format of the thesis you are asking, I'll come one by one. For the specific details means, see, already we'll have for specifications, I'll tell you what to do. See, for Raspberry Pi 4 you have got already a specification. Okay, you are talking about specific details. I am telling, I will come to that only. So okay, here Raspberry Pi 4 model is there. You have got a specification here. Okay, so what you will do is, this specification is there, right? In this a particular pin in which we are going to connect the that's what that specific means, that only. uh, Here, in a particular pin where you want to connect the heart rate sensor, that is specific. You can use 17 or 18, that's what we have discussed in now. And then MOSI, that particular pin you have to use it for SPI. Okay, and then ground, that is when you are connecting a MCP 3005 3004 channels, this channel will be connected to this one. This can that last in the last class I think we have discussed, for each channel which channel we are going to connect which output, x direction, y direction, z direction, and then the BP output. All the four for each channel will be connecting. So channel 0, channel 1, channel 2, channel 3, which one where you are to connect, and then it is connected to SPI through MISO. So that will be received like that. The pin pin names, if you are able to tell, that is what is specific. Okay, I think we have discussed about that in the previous class for the specific pin details. That's what they are asking. I'll try to make a diagram in KiCad, and I'll send you. When you see the diagram, you'll get to know specifically where what is connected. Okay, and then the power supply, 3.3 volt is the power supply. Actually, when you can there are sensors which will work in for 3.3 volt and sensors which will work in 5 volt. So for that, we are actually taking the power from Raspberry Pi itself. But to power the Raspberry Pi, what we are using a power bank. I hope I have answered this right. See, project report, the format will be given in VTU's website. So just copy that format, just download that format, remove the head, remove the topic, place your topic there. Like that you have to do. See, there is a Word format will be there for the project report. Okay, that format you download it. Wherever title is there, remove the title, place yours. Yeah, in that you just remove the title, place your title. Like that you do it, replacing the same what is that your if it is 16 is the title's size, means you change it 16 in your file and copy and paste it in that file. Like that you do it, then only format you can maintain until the end. Same format you can maintain. If not, that margin, everything will get you will lose the margins, size, all those things. Instead of that, same format, in that only you just place it. That is better. Yeah, that is the best way. Even what I am suggesting you is yeah, we can use the temperature sensor. If we use temperature sensor, then we have to go for MCP 3008. We have to change that to because one extra ADC will be needed. So 4 pins are already busy, so we can't use MCP 3004. We can use MCP 3008. We can use temperature sensor also, we can use. But we can't use 3004 now. We have to use 3008. But we have not given that temperature sensor in the initial material. We have told that we are just using only 3 sensors. If temperature sensor no, I don't think temperature sensor is important for heart attack detection. I don't think. That you have to check. Maybe temperature drop will be there. That has to be checked. But heart rate is the main thing that will be helping you for finding out the heart attack detection. Maybe because of the lower blood pressure, there is a chance of reduction in temperature that can happen. That we have to if I'll just check that and tell you if there is a is it needed or not. That will have a finalization. Temperature sensor, I don't think it is needed, but if it is needed, I'll tell you exactly how why we are using it. Those things will finalize. Okay, then in the coming class what we'll be having is GPIO. Will do it in the coming class. First class will be going with the GPIO, and then the second class MCP 3008 will go, because MCP 3008 needs a complete 1 hour for discussion. For GPIO, I think it takes only 20-30 minutes, but as it is new for you, initially Python writing the code, all those things I'll discuss, and then I'll go for GPIO. So that's why I'm taking 1 hour for that. So GPIO will finish it, and then we'll go for the next one, that is the MCP 3008. If temperature sensor is needed, then MCP 3008 will go for. If not, 4 only will take it. Yeah, if there is any other doubts, you can ask me. Yeah, then shall we wind up the class now? I hope it was useful for you. I have recorded the video anyway. I'll share that. I'll upload in the YouTube, and I'll share that to you. Yeah, thank you everybody. Yeah.